slide?
Recording
Recording
start.
started.
Okay, fine. So I think we finished with the valency. The valency is the number of electrons present in the outermost shell. That is the capacity of an atom or an element to combine with another atom. That's called valency. Why are they doing so? To become a bond, isn't it? When if they don't combine, from where we will get the bond beta? So we get bond by the combining capacity of the elements or the atoms. Is it understandable? Hello. Is it understandable, beta? Hello, say something.
Yes, ma'am.
Yes? Okay. Now I told you regarding the cations and anions, isn't it, beta? Cations are positive and anions are negative. Remember? I had told you to revise the uploaded video. I hope I just pray that you have done so. Then only you will be able to understand nicely. Now you see over here, we'll go one by one in the series. Sodium. Okay. What is written over
Yes.
here, beta? Na plus. What is written? Na plus. That means it can give one electron. K plus one electron. Na plus is sodium Na, potassium is K, silver Ag plus, that is silver, again 1, Cu plus, copper 1. Now we come to magnesium. Now magnesium has got 2 plus, right? That means 2 electrons. Is it clear now? Calcium 2 plus, 2
Yes.
electrons. Zinc 2 plus, 2 electrons. Have you understood this much? The number of ions shows the number of electrons. Is it clear? And plus means what? It is given. What is plus beta? It is given. Minus, it is added. Is it understandable to all of you? Yes?
Yes.
There's some more. We'll see that. Iron, Fe2 plus.
Your screen is not visible.
What about others? Can you see my slide?
No,
No, ma'am.
no, ma'am.
You can see my slide. If someone is presenting or what,
No, ma'am.
No,
then I
ma'am.
can go back. Is it blank? Absolutely. Now can you see?
Ma'am,
No, ma'am.
your slide is not visible now only.
Okay, we'll go back. Don't worry. Now,
No, ma'am.
now can you see?
No, ma'am.
Yes, ma'am. Now sing.
You can see my
Yes,
screen
ma'am.
at least, right? Now, can you see the things? Now?
Yes, ma'am.
Okay. Something must have happened. Okay. Now see over here. Iron Fe2 plus. Can you see the font? Is it clear to all of you? Or do you want me to magnify it?
Yes, ma'am.
Is it okay?
Yes, ma'am. It's okay.
Okay. Then we have iron. Valence is 2. That means number of electrons at the outermost shell is 2. Cu2 plus copper, number of electrons and outermost shell 2. Then we have aluminum, that is 3 plus. What do we have? Aluminum 3 plus. This is aluminum and the valence is 3. Is it understandable? So whatever plus and minus you see on the top as the superscript becomes the valency. Okay? Now we come to hydrogen. It is H plus. Okay? So what it is? Valency is 1. Just show you like this so it will become easy for you. So hydrogen plus, it is valency is 1. Right, beta? Hydride minus, valence is 1. Chloride minus, valence is 1. Bromide minus, valence is 1. Is it clear?
Yes, ma'am.
Is it clear? Iodide, this is valence is 1. Remember that. Oxide O2 minus, valence is. Is it understandable? It is O2 minus, so valence is 2. Is it clear?
Yes,
Yes, beta? Then we have nitride. That is 3 minus. Valence is 3. Now ammonium, NH4 minus. These are the formula that you have to remember, beta. So you have to write at least 5 times the chemical formula or the molecular formula and the name. It's clear? This is how you will remember. Valency 1. Hydroxide,
okay.
valency 1. Nitrate, NO3 minus, valency 1. Hydrogen carbonate, valency 1. Carbonate, it is 2 minus. Can you see this on top? 2 minus, valence is 2. Sulfate, not it's not sulfate, sorry, it's sulfite. SO3. Sulfate is SO4, remember that. So valence is 2. Hope you have understood this much. Whatever is on the superscript, that becomes the valency of that
Yes,
particular ion. Is clear? So
yes,
please,
sir.
the other one is phosphate. Can you see this? This one. PO4 3 minus. What will the valency beta? 3. So please remember, you have this in the book as well. And please learn. You have to learn it. You have to learn all this molecular formula, the name, and their valencies. Now we come to ionics. Ions we have seen. From the ions, what we get is ionic compounds. So let's see what exactly are the ionic compounds. Read better.
Ma'am,
Start
can
to
I
read.
read?
Okay, beta.
Compounds in which molecules are formed by the combination of cation positively charged ions.
Cations. Beta, it is cations.
What, ma'am?
It is cations.
Cations, positively charged ions, and anions, negatively
Anions. It is not onions. Sorry. It is anions.
anions, negatively charged ions are known as ionic compounds. For
Please adjust
example,
your mic. Adjust your mic.
compounds in which molecules are formed by the combination of cation positively charged ions and anions negatively charged ions are known as ionic compounds. For example, zinc oxide ZnO. This is formed by the
Then please
combination of
adjust
zinc.
your mic. You got some noise from your background. Is someone in the Google Meet? Because you just shift from that place, if possible. Thank you. Start.
Combination of zinc ion Zn2 plus and oxide ion O3 minus.
No, O2
Other
minus, beta. It's O2 minus.
auto minus. Other
Okay.
examples of ionic compounds are magnesium chloride MgCl2,
Very good.
potassium bromide KBr, sodium chloride.
Yes, say the formula.
Sodium chloride NaCl, etc.
Okay, good. Now we will see the compounds where the molecules are formed by what? By combining of cations and anions. Is it clear? What we had taken earlier, beta? We had taken NaCl. Remember? What is the combination? It is Na plus and Cl minus. Right, beta?
Yes,
Hello? Yes? So this is the combination of. Now what is Na plus? Cation. What is Cl minus? Anion. Is it clear? So we are having a combination of these elements, cations and anions, and we get a molecule of one molecule of NaCl. Obviously, this is a compound. So compound are made up of molecules, and these molecules are the combination of cation and anion. So these becomes ionic compounds. Is it clear? So what is Na plus Cl minus? It is ionic compound. Is it clear to all of you?
yes, ma'am.
Boys? Huh? Okay. Now let's take zinc oxide. How it is made? 2 plus and 2 minus. Remember always, this has to be cancelled. 2 plus and 2 minus gets cancelled. So it becomes ZnO. Remember that. Because actually, any compound you make, it has to be neutral. I repeat again, it has to be neutral. If the cation is 1 plus, then the anion has to be 1 minus. If the cation is 2 plus, then anion has to be 2 minus. If the cation is 3 plus, then anion has to be 3 minus. Is it clear to all of you? Because the compound has to be neutral. It cannot be charged. Hope you understand?
Yes, ma'am.
Yes. Okay. So what we get? We get Zn2 plus and O2, sorry, and O, I just put it down, Zn2 plus and O2 minus. Is it clear? So this gets cancelled and it becomes Zno, electrically neutral. This is how we get. Is it clear?
Yes, ma'am. Clear.
Yes. Same way we will see as magnesium chloride Mg2 plus Cl2 minus. Is it clear, beta? Hello.
Yes, ma'am.
Yes, ma'am.
Similarly, we have K plus and Br minus. So it's all cancelled. Can you see this? And they form MgCl, KBr, NaCl, etc. Do you want to ask me any question regarding ionic compounds? Hello. Do you want to ask me any question, beta?
No, ma'am.
We'll see the ionic compounds. Yes. The ionic compound, I will read it out, beta. Calcium oxide. If we take calcium oxide is made up of calcium and oxygen. By mass, the ratio is 5 is to 2, but by number of ions, it is calcium and oxygen. What you will write? 2
Yes, ma'am.
plus and 2 minus. Is it clear? So 1 is to 1 ratio. Magnesium chloride. It is made up of magnesium and chlorine. Ratio by mass is 24 is to 771, but ratio of ions is 1 is to 2. Okay, because MgCl2. It is 1 and it is 2. Is it clear? You understood or not?
Yes.
Aluminum chloride, I think this is. So half is not written. AlCl3. So what is Al2Cl3? Okay, aluminum chloride. So by
Yes.
mass it is 27 is to 32, but by ions it is 2 is to 3. You don't have to remember all this table. It's just for the general view that has been given to you. Okay, so don't worry about this.
Yes, ma'am.
Now, how to write chemical formulae of compounds? That's very important. Please begin with it.
Chemical formula of a compound is the symbolic representation of its atomic constituents. In other words, a chemical
Please adjust your
formula
mic.
represents the composition of a
Adjust your mic,
molecule in
better.
the symbols of
Better
uh,
adjust your mic. Lots of noise is coming from your background. Yes, continue.
in other words, a chemical formula represents the composition of a molecule in terms of the symbols of the elements present in that molecule. To write the chemical formula of a compound, one should have prior knowledge of two things: the symbol of the constituent elements and the combining capacity of each atom constituting the compound.
So what exactly is chemical formula? If I say magnesium chloride, are you going to write magnesium chloride while writing the chemical equations?
No, ma'am.
No, right? So what do we have to do? What do we have to do, beta?
Real.
What do we have to do? We have to write down the symbols to make it short, isn't it, beta? So it becomes very easy for us to convey the message, for us to write down the chemical equation. Is it clear?
Yes, ma'am.
Okay. Fine, fine. Just a moment, beta.
Okay.
So the formula 43310. And give me some time.
Okay,
Third lecture I'm
ma'am.
free. So the chemical formula shows that what it is made up of. What are the atoms present in that compound or the molecule? Okay, beta. So the molecule is actually made up of elements. Now I cannot write chlorine, CHLORIN. Instead of chlorine, I will write Cl. It becomes very easy for me to show. And in a small space, I can fit the chemical equation. Isn't it better? So for writing the chemical formula of a compound, we should know two things. What is that? First of all, I've been telling you again and again, please learn the symbol of the elements. You remember that? When we had started with this chapter, the third chapter, that time I had asked you, please start learning the symbols of the elements. That you should know. Secondly, the combining capacity of each atom, like NaCl. So we know that Na combines with Cl. KBr, it is forming KBr. So we should know the even the names of the compounds. That will you will learn along with the practice, so don't worry about it. But these are the things that is very essential for writing a chemical equation. Okay, beta?
Yes.
And so what is the combining capacity that we know already know? We call it as valency. Please read better.
We know that the combining power or the combining capacity of an atom or an element is called its valency. The number of atoms of other elements with which one atom of an element combines is decided by the valency of that element. For example, both hydrogen and chlorine have a valency of.
One,
Therefore, one
one,
atom
one.
of hydrogen
Read better.
reacts with
Valency of
one
one.
atom of chlorine to form one molecule of hydrogen chloride.
Are you able to hear me?
Yes, ma'am.
So I said valency of one. You did not repeat better.
Chlorine have a valency of 1.
Hmm.
Therefore, one atom of hydrogen reacts with one atom of chlorine to form a molecule of
It
hydrogen
is
chloride.
chlorine.
The valency of an ion is equal to the charge on it.
So you got it? What is valency? If I say Na plus, so what is the charge? Plus 1. So what is the valency? 1. Do you understand?
Yes, ma'am.
Similarly, chloride minus, what is the charge? 1. What is the valency? 1. Is it understandable to all of you?
Yes, ma'am.
So the presence of the electron in the outermost shell, which is showing the ion, is called the valency. That I hope you understood. So the capacity or the number of atoms of any other element by which the other atom is combining, who decides beta? Valency. Who decides? Valency. How one atom will combine with the another atom will be decided by the number of electrons present in the outermost shell, which is called as valency. Is it clear to all of you?
Yes, ma'am.
And this combining system is done by formation of, what is this beta?
Bond.
This also we have studied earlier.
Yes,
For
ma'am.
example, let's take hydrogen and chlorine. Okay, hydrogen, it is plus, chlorine, it is minus, right? What is the valency? 1 plus, so 1 valency, 1 minus, 1 valency. So one atom of hydrogen reacts with one atom of chlorine, and what it is forming beta? HCl. So we don't write plus and minus. It gets cancelled, so instead we write HCl. Is it clear? It's clear to all of you?
Yes, ma'am.
So what is valency of an ion? Is the charge. What is the valency of ion? Is the charge. Is it understandable? If I say
Yes,
valency of hydrogen is what? You will say 1. I will ask you, what is the valency of chlorine beta? Or rather chloride? You will say 1. Is it clear to all of you? 9 standard.
yes,
What about, only you are saying yes. What about rest of you? 9 standard, are you there?
Yes,
Hello?
yes, ma'am.
Do you have any doubts? Just
No,
clear it
ma'am.
right now.
No, ma'am. No, no.
All of you are understanding or not? 9 standard? Hello?
yes, ma'am.
Yes, ma'am.
Okay. I'm taking some more difficult ones now, or the combination of iron, aluminum, you get Al3 plus, what is the valency? 3. Right, beta? Ammonium, carbonate, it's just the carbonate.
Okay.
Something wrong, beta. We will not take this. Calcium, 2 plus, it's 2. Copper, 2 plus, it is 2. Hydrogen, only 1 plus, it is 1. This is not right, beta. This is wrong. So don't take this. If it is ammonium, it should be NH4 plus. Is it clear? Then your answer is 1 right. It has to be ammonium, has to be NH4 plus. Okay. Now we can take sulfite. Sulfite is 2 minus. Can you see this 2 minus? So it is 2. Bromide, 1 minus. 1. Carbonate, 2 minus. It is 2. Chloride, Cl minus 1. Hydride, H minus 1. Is it clear? This is hydrogen
Yes.
carbonate. This is hydrogen carbonate. Only 1 minus. So it is 1. So whatever minus you see, either this 2 minus or 3 minus or only 1 minus, it depends on the valency. You can say that these are the valency. Based on the number of ions, you can define the valency. Now, whenever you are writing any chemical formula, you have to follow certain rules. Let's do one by one. Yes, Beta. Can you read?
While writing while writing the chemical formula, certain rules need to
Kept.
be kept in mind. These rules are given below. The valencies or charges on the ions must be balanced.
This is very important. Didn't we balance it? See, we started with Na plus and we started with Cl minus. So it is balanced and we cancel it, isn't it? We cancel it. And what do we write, beta? NaCl. We don't write like this. We don't write like this. We write like this. Is it clear? Hello? But it is made
Yes,
of plus and minus. Remember, it is made of plus and minus. But we write like NaCl. That means the ions are balanced. Okay? Next.
yes. In case of a compound consisting of a metal and a non-metal, the symbol of the metal is written first.
So first is this one. The valencies on cell must be balanced. Second is symbol of the metal is written first. This is second. That whenever you are having a combination of uh, say a metal and a non-metal, for example, sodium chloride. What is sodium beta? It is metal. And what is chlorine? It is non-metal. Right? Hello.
Yes,
So what comes first? Metal comes first. All of you understood?
yes.
Boys, next.
For example, in calcium chloride, CaCl and zinc sulfide
No,
is
no. Beta,
ZnS.
it is CaCl2.
CaCl2 and zinc sulfide is ZnS. Calcium and zinc are metals, so they are written first, whereas chlorine and sulfur are non-metals.
It is
Number
chlorine
three.
beta.
Number
It
three.
is chlorine.
Yes, chlorine
Okay.
and sulfur are non-metals.
So
Number
now
three.
in CaCl2, we can see Ca is metal, Zn is metal, right? So they come first because they are metal. What are non-metals? Chlorine and
Chlorine and
sulfur. So
sulfur.
they come next. Is this clear? the the rules and regulations, how to write the chemical formula. First is that the ions must be balanced. Second is if it's a combination of metal and non-metals, metal is written first followed by the non-metal. Is this thing clear?
Yes, ma'am, clear.
Yes. Okay. Now we come to the third.
Third,
Read.
in case of compounds consisting of polyatomic ions, the polyatomic ions are enclosed in a bracket before writing the number to indicate the ratio. For example, in aluminum sulfate Al2SO43, the polyatomic sulfur ion is enclosed in a bracket before writing.
So whenever there are many atoms forming a compound, many atoms, that okay. So how many atoms are there in this case, Vita? How many atoms are there? Al, S, and O. Three atoms are there, right, Vita? Hello, hello.
Yes, ma'am.
Yes. So three atoms are there forming polyatomic ions.
Yes.
What have they done? The polyatomic sulfate ion is put in the bracket. Can you see this? Is put in the
Yes,
bracket.
ma'am. It is put it in bracket.
This is how it is symbolized. This is how, because it has to show the ratio between the aluminum and sulfate. Because how it is written? It is aluminum and sulfate. SO4 is totally separate and Al2 is separate. So this is showing the ratio. It is showing the ratio is 2 is to 3, isn't it? Aluminum is 2 and sulfate is 3. So what is the ratio? 2 is to 3. So that bracket shows the ratio. Is it clear to all of you?
Yes, ma'am. Clear.